finger knuckle print recognition, and the author of the paper was David Zhang. These are the steps involved in biometric recognition. I have to do feature extraction and matching.
What is Ruby? Ruby में है?
I have to implement. I have implemented the technique of which they presented in this paper. They called this technique as local feature integration (LFI), and I have to report the equal error rate and CRR. This was the first part of the question. Second part of the question was to implement a global feature along with these three local features. So the first approach was the detailed approach. Part one is extracting the local feature. First local feature is phase congruency. Calculate phase congruency. We first apply log-Gabor filters over 6 orientation and 4 wavelet scales. So this orientation is basically the angle of the filter. And Venkatesh and Owens has previously found out that phase congruency is local energy upon phase congruency at an orientation J is local energy at an orientation J upon summation of amplitude over all the scales at that orientation. So for this to calculate PC, we need local energy and amplitude. First, to calculate amplitude, so that when we take the when we apply the log-Gabor filter, we get real and imaginary values of the convolution result. Amplitude is nothing but the absolute value of the result. And so suppose the orientation is 3 and scale is 1. I got this amplitude, and I have to sum this over all the scales. So after that I will get the denominator from this equation. To get the energy, we first sum the real part of the convolution results over all scales and at that particular orientation. Then we sum the imaginary part of the convolution result over all scales, and the energy is defined as the absolute value. So now we have phase congruency for all orientation. So the final phase congruency of the PC code map we will use will be the maximum among these all phase congruency among these orientations. So like the orientation for which PC is maximum be M. This will be needed in calculating phase, local phase feature. So local orientation of this is the second feature, local feature. They are calculated by by using this function. E we have calculated previously that it is the real part of scale 4 and at orientation J. They used scale 4 because it gave them the maximum result. It gave the maximum. Then phase is defined as this is this equation. In this equation I was given. Hj and fj were the summation of even the real part of the convolution result and imaginary part of the convolution result. And to calculate the phase code map, we have calculated at that m value which we found out earlier. So the global feature they used was the Fourier coefficients, and they have calculated it by first transforming the image. First calculating the Fourier transform of the images, then finding the cross phase spectrum, and then finding the POC function. The peak in the POC function will denote that how similar is the images, and to get the global distance, they have just done 1 minus peak of the POC function. So this is the result I got. Actually, 68% was the CRR and the ER was quite bad. So this is the claim. Actually, I think So it was very. So I think because of the database, I think the images were not too good ROI.
Are you sure that you have implemented correctly?
Yes, sir, correctly. Sir, even I calculated the same code which it was used in phase congruency without any change. It also not gave me the correct result.
FKT or up. It is implemented, but result is very poor.
Very poor. What is the accuracy?
Accuracy 68%, but ER which was they showed was about 20.
Because there are several parameters, and have you checked? You have matched same image with the same image, and it is giving you what score? One.
Yes, sir. It was giving me one. Matching distance was giving me one.
Come करो, ये मुझे demo देखो.
ठीक है.
What is the database?
Sir, 616 to 660.
No, but
Poly U.
so you show him the demo, huh? Ajay, next.
Hi, so I'm Kanesh and I'm here to present on my project topic, iris image quality estimation. The problem statement was that I would have to analyze the quality of the iris images that were taken near infrared illumination. I have done that for the dataset of KCR interval and to identify and quantify the possible parameters that affect image quality, and then try to fuse the scores for every for the parameters and then into a quality level. As just a recap of the last presentation, the quality attributes that I have used are of two types: univariate, bivariate. Univariate attributes are those which assess the quality without having any reference images. And bivariate are those which assess the quality with respect to some reference images. These are the quality attributes that I have used in this focus, occlusion, illumination, specular reflection, off angle, and correlation, luminescence, contrast. The approach, that the difference between the earlier work and my work has been in focus, off angle, correlation, luminescence, and contrast. I come to off angle or segmentation error. Actually, the idea of the approach was I would whenever you try to segment an image using Dugman's circular integral operator, what it does it assumes the pupil and the iris to be perfectly circular. But for an off angle image, that is not true. So in that case, I was expecting that the segmentation that I would be getting would be such that either this would be having some part of the pupil at very close radius. So I analyzed the top layer, as in the top 20 pixels of the normalized image, and I saw how what was the intensity of that, and then I used this formula. Basically, this is the cropped image, and this is the average intensity, just to have a normalized measure for all the images, and then this is the normalizer. What parts?
Why 300?
So actually, it is not necessary that this value stays under 255. As in, this can very go above that.
300 उसकी maximum value है.
As in when I tested for the database, yes sir. As
जो
a
बोलो वो maximum
yes,
value है.
for the LAM database, this was the maximum value that I was looking at. As in roughly, approximately.
No, it's the mean average mean value, right?
Yes sir.
Mean of one image minus mean of another image.
Yes sir. This would actually, when this is smaller than this was going above one, which I did not want it to be. Or unless
What is the maximum value of mean?
the maximum value of mean, as in I did not calculate that.
If it is a white, whole image is white, what is the mean?
255.
This is the maximum
Yes,
value.
sir.
What is the minimum value?
0.
0.
Yes, sir.
So this mean minus mean should be maximum 255.
Yes, sir.
Why you are dividing by 350?
As in the, it is probably a mistake. Actually, I calculated the value for this, and the maximum value was coming over 1. So, sir, this mean I, this is a mistake actually. This is not what I'm realizing. The mean I, it can be greater than the mean I cross. So this in turn, there is a negative sign here.
Difference is the
Yes, sir.
result, right?
Yes, sir.
Absolute value. Difference.
Probably I could have skipped this and
Absolute value. Difference. Difference. Yes or no? So
Yes.
this is 300 is not a correct thing. You have to put it at positive value of this difference.
then actually this did not yield good results because when I assumed that the pupil would be elliptical, I imagined the pupil to be like this, and the segmentation to identify the circular pupil as this. So this black part would have been in my normalized image. This is what I was trying to analyze. But in some of the cases, when the image was off angle, what happened was the whole of the ellipse was enclosed, and instead of this, the white portion of the eyeball was included. So this actually did not yield very good results. Then I come to focus. For focus, I selected 2 regions of interest on the iris, and I took that region of interest which had maximum points in between the thresholds. The threshold selected were 30 and 240. It was tested. It was come to conclusion by some iterations, and then this kernel would be applied, and then the focus parameter was calculated. For this image, the focus parameter was 0.2140. As you can see, this is a bit blurred, 1715, and then you can see the values here as well. The maximum value that I got for the database was 0.32, and the minimum was around 0.11, I suppose. I'm not sure about that. This is again for another image, 0.182, 0.1520. So how is this method a better method than the previous one? Suppose, as I had mentioned earlier in the earlier presentation, suppose there are some defects in the region of on the iris normalized image. What the previous method was doing was, it used to take the top half, as in the top right quarter of the image, and evaluate the values of the convolved image. But for that case, as in this, actually the picture quality is not too good. The focus of this image was very poor, and because of this bright values, the earlier method showed 0.2841 for this image, whereas the average value for the CASIA database was 0.2250. My average value for the CASIA database was 0.2331, and for this image 0.1476 came. These are the results for the focus parameter. On this, all these results are based on CASIA interval data set. Now I come to the bivariate measures. Now in the bivariate measures, I converted the images into one-dimensional array and calculated the standard deviations between the 2 images, and also the mean of both the images. Now, as pointed out by sir in the last class, there was a problem when you could not actually, if let's say there is a shift in the code, then it requires some image registration. But the approach that I have taken to encounter that was, I took a 4x4 window to evaluate all the 3 parameters, and then I took the product of these. So this was summed and averaged by sliding the window on the entire image. So actually this actually indeed reduces the need of the registration of image, because I am assuming that in an iris code the values do not change very frequently. As in this, in a 4x4 window, the images can be assumed to have similar values. So these are the results of the bivariate score. This is 0.218 and this is 0.547 and this is 0.682 and 0.6740. Basically, this bivariate score is not the absolute measure of quality. It just measures in terms of luminance, contrast, and the correlation with respect to some good images. Now I come to the contrast, bivariate contrast measure. Now this is a plot versus the new contrast versus the old contrast measure. So as you can see in the image, there is quite a correspondence between the old and the new method, as in the values here lie close to each other and mostly are concentrated here. So as it almost evaluates the same thing as the old method, but the method is completely different. It is bivariate, as in it compares to some images. Now I come to the luminance. As you can see, this is the intensity of this image is very poor. It turns out to be 0.4693, and this is 0.8332, 8489. Now the correlation measure. These are the results that I obtained. The most important thing while selecting the ideal images was I tried to take care of occlusion, as in I took less occluded images. So as you can see, this is a very occluded image and the score of this has suffered because of that. Similarly here, the bivariate measure came out to be about the same for both these images, but for this image the score was 0.298, whereas because it is occluded the score came out to be 0.1159. These are the statistics for the Zeya interval. I evaluated over these all these methods, and this is for LAMP. This is the whole code was run, but the images was not analyzed from LAMP. Now quality classification. Actually, I implemented the code for the name-based classification, but since that requires manual labeling of all the data points of the quality, as in one person has to sit down and say this is a good quality and label it on a scale from 1 to 5, or how many, or in ever how many classes do you want. You'll have to label it manually. So this was not manually labeled, as the code was run for random assignment of the quality levels. Hence the result is pointless, but the algorithm is there. And these are the differences.
How can you tell what are the parameters you have considered? You have done it correctly.
So the results of contrast came out to be very good, and the result of correlation was good, but I cannot, since it was not tested on a very large data set, then I cannot say that it is correct. But the results that I got for some images were very nice, and for focus, I believe it was better than the earlier method that was there. And moreover, this last part,
Because you have to justify. Maybe you spend half a day. Aditya, you were there for some time.
Yes.
Just to justify
Yes.
that whatever parameter he has considered, they are properly correct. That is important. Otherwise,
actually, that was the trouble that I was facing, as in I could not use a recognition algorithm to give the results. Otherwise, that would have been a good parameter to determine whether the quality is good or not.
can you sit after this so that there's more day to tomorrow?
Yes, sure.
Myself Akshay Khurana, my roll number is 99305. My project was the finger. I have the finger knuckle print image enhancement. So the problem statement is I have been given a finger knuckle print image, and I have to enhance the image for better recognition. So the method that I used, so I
divided the given image into sub blocks of like 10 by 10 blocks, 10 by 10 pixels, and then I have to first actually uniform the brightness of the given image. So first I divided the given image into 10 by 10 blocks, and then calculated the mean of every block, and then then I expanded the image to the original size using the bicubic interpolation. So and after that, like for obtaining the uniform brightness, the image that I got from that previous step, I subtracted the image using some parameters to obtain the uniform brightness of the image. And after that, when I got the uniform brightness image, then how to enhancing for calculate the histogram equivalent of every 10 by 10 blocks. This 10 is chosen by running on several times with several other parameters like 9, 10, 11. So the histogram equation has been calculated using for every 10 by 10 block, and then to improve the smoothing the borders and all, I use the different filters, average filter and sharpening filter, to obtain the required image. These are the results for the given dataset. This is the original calculated image that I have given.
Run it. What is the difference? Color image, subplot. What it does? First one, subplot, block. While
This one?
no, that is image.
This is the for each 11 by k size for each 10 by 10 block.
Oh.
This is how it calculates the sum for each.
Sum. Then next.
Then
so
this
you
is
got
the
the sum.
This is got the sum.
By k square. You got average.
Yes.
Then?
And then this loop ends here. And after that the bicubic this is the bicubic interpolation. So it does the bicubic interpolation, and then after that for each 10 by 10 block it calculates the. So this is the subtraction.
इवन डिफरेंट मतलब अपने में हम लोग का ब्लॉक फंक्शन होता है मैटलैब में, वो इस्तेमाल किया है.
Actually, what I wanted, that part here, go back to the image, the results. Actually, what I wanted is different. Remember what I wanted?
Enhancing the.
I wanted the lines to be visible, rest should be somewhere. Fingerprint, how is the fingerprint? Some lines are there. Same thing I wanted only lines should be, rest I don't want. So binarized image. Theme binarized image. What I wanted, theme binarized image.
ऐसे सर वो कोई एक स्टूडेंट फार्म के ऊपर भी कुछ कर रहा है, जिसमें कि वो लाइंस.
हाँ वही इसी तरह चाह रहा है. So that I want to see whether Manisha points can be used. I think I turn on.
My project topic was string and other quality parameters. Coming directly to the implementation work, edge detection was applied using Canny edge detection. and then the mean of the pixel values was taken. So the mean of the pixel values were giving me a very low score, so I normalized it over the whole database, and the higher the value it represents in the database, the image is better. So here the graph plotted for the graph is plotted for the whole database. The frequency, here one value represents 0.001 value score. So it's the frequency that how much score is, how many images got this score or like that. So in this edge detection, many images lie in this area, and for the top images they are very less, which have got very better edge detection. So due to reflection, these images are not clearly visible, but these images have a very good edges in them, and we can see in these images the edge is there, but there is a single edge. There is no bifurcations or other edges coming out of these, and the values are shown, that scores are represented, and we can see that for a same user the value is coming very good. So it shows that when the image was taken for the same user, it was taken at that time the efficiency was good. Now another parameter I used was specular reflection, and for specular reflection I used threshold technique, and that the image with the more reflection is poor quality image compared to others, and the parameter gives lower score, and which was normalized. And here the majority of the database doesn't have the specular reflection. Very less of the images have specular reflection, and these are database images. These images have nearly zero specular reflection, and in these images we can see that due to this specular reflection the edges are not visible. So good quality images and bad quality images. And then finally I applied entropy. I take the image and divided it in 10 cross 10 block, and calculated entropy on each of the block, and the mean was taken on using the weighted, and weight was calculated for each block on the basis of the edge parameter I defined earlier, and I take the mean to define the entropy of the whole image, and the score was again normalized over the database. And so this code was actually taking too much time to run, so I haven't got much of the test cases. I have run it in a spot.
You are finding the entropy, right? Finding entropy, why it will take fast time?
So actually on the whole database taking the longer time. I have run it on a small database, and I have got some of the results, and we can clearly see that these images are showing edges, more edges, and on the prominent edges there are again small edges coming. These images are having them, but in these images we can't see other bifurcation and different
Only top two.
because the database was very small, so I have taken only top 2. I have only done it on 120 images, so
120 में top 5 कर दिया है. बाकी सब पे 0 आ रहा था क्या?
नहीं, I can show the result on my laptop. I took it as a ratio because I was taking top 5 from the 70.
इसके बाद वाली में you have checked. इसके बाद जैसे second के बाद top 3rd या.
I have checked. They were all like in a decreasing order. I can show on my laptop. I tried plotting the graph, but on a small database the graph was not very good.
So can you do one thing? That can you take a large database and
Sir, I would try to present it on 15 morning.
What you will be doing, let me tell you. तीनों parameters के लिए top 5, at least top 5 or 10 images you show.
Yeah.
Good, bad or worse. Third is after this. You show then there are 3 अलग-अलग parameters, try to fuse them. यूज कैसे करोगे स्कोर लेवल पे आप तीनों को सेम वेट दे करके यूज कर
Yeah,
दो.
I was thinking about fusion technique, and like we can see in this specular reflection. These images which are top one, they don't have specular reflection, but they are very dark. So I was thinking of giving less weightage to the specular reflection part and more to the entropy, which is giving me for now good results, and the edge part.
और जो पहले वाली दो थे वो पूरा you have worked on local dividing into blocks and doing that, or also you have done it on the whole image?
On the whole image. If I am using only one parameter, then dividing it into block, but I have to take a weighted, so I have to use another parameter for them. So in entropy, I use my previous edge parameter for weighing the entropy.
You meet me after the class, so I'll tell you what is the thing. On Monday, 15th, you will be showing the thing. Right?
Okay, I was on, and the entropy one I would be showing on the 15th. I could get some other parameter also. I would try to show it. Thank you.
So this is the classic way of sorting. Basically, generate the random number, random matrix, and take it the dot product, and after thresholding it's stored. So what I did is basically I read the template for the registration part. I read the template and generated a token matrix and associated it with a key k, and I'm storing the key in my database, not the random matrix. And after auto normalizing it by using the MSC process and inner product and set as the final template. And for the verification part, when a user gives its biometric data, so using his user ID, I retrieve the key and then generate the token matrix. And again the same procedure, automate the random matrix and inner product, and after thresholding, I compare it as a new template for matching purpose. And as a matcher, for the matching purpose, I have used the handling distance approach. And for the template, I tried it on the two templates of form. One was a 2D Harvard transform, and second one is phase difference. And apart from the classic approach, there are a few things I have added. One is I have done basically added a function in the template which is dependent on the system variable. Basically, it's a fix for one system. And after that, I did the sorting. Basically, one more addition is basically the user when he will register, we will provide him a key, basically a value X, and when he will come again for the verification in the login, so we have designed basically we have implemented a function of as X to the Y. So after he will give the biometric data, we will provide him a Y. Then he have to enter any value from this hash function. So, and these are the basic.
Did you implement all this?
Yes, I'll cover it in the next one. And for the basically protection schemes, diversity is covered because of system variable. Two systems cannot use the same biometrics template, and removability is covered since we are storing the template by using a key, so we can replace it if the current template is compromised or stolen. And non-invertibility or privacy is cared by basically so many operations on the template. And performance, this is the part I need to check. Basically, I've just got the database which I have to work on. So I did the registration part, verification part, matching, and I've used this token random token generator and basically now I have to just do this performance check. Others I do. So this is just I tried it in the class on data of 500 templates. I just tried basically I stored the first your template, then on the verification of the same user different template, and this is the matching.
ये रिजल्ट कब निकला? 500 की कितनी मैचिंग की?
500.
क्रॉस 500 मैचिंग, टोटल कितनी मैचिंग है?
Actually, just one-on-one matching. Same
मैचिंग
user.
कौन सी है?
This Hamming distance.
टेम्पलेट क्या है?
Palm.
0 1 वाला?
0.
मतलब ये 0 1 पे चलेगा?
Actually हो जाएगा. Actually 0-1 पे as a template अगर store करते हैं, and after that random matrix is a basically dot product लेता है, तो it's same thing.
Always take the. So when can you complete the thing?
Sir,
Huh?
I have just to run the system.
When can you complete the whole thing?
By tomorrow morning.
By tomorrow morning. So talk to Kamlesh, take time. I'm giving up to 15th. By 15th, I must get the feedback from Kamlesh. Otherwise, whatever I have, I will bring them there. I will.
Yes. Most of the things are.
I don't know. Whatever I'm telling you, that whatever you have given, based on that I will grade. Otherwise, you can give it to Kamlesh. Let Kamlesh give me the feedback.
So basically, my project is on biometrics faulting, so it's done. I will just show the results.
This is the absolute result, or I have to evaluate further?
Yes, I need to show you the results.
So show the result and then.
I'm working on principal lines extraction from a given palm print. So the problem statement is to, given a palm print, I have to extract the principal lines of the palm so that it can be used to generate a biometric key. So previously I implemented an algorithm. So what that algorithm did was it enhanced the image by dividing it into block of size 16 × 16 and subtracting the mean from that. Then I applied smoothing filter and then convolved the image with Sobel filter to get considering the lines to be edges. I detected the lines using the Sobel filter. Then small holes were filled by closing the image, and these holes and this image was merged with the gradient image, and the binarized image was created from this by automatically predefined threshold. And then the connected components were found, and the big connected components were presented as the principal lines. But we saw that this algorithm was not giving good result. So we implemented another algorithm. In that algorithm, we define basically a kernel of size p × p, which is ZP, where p is any number. So and for any LK denotes a line that is being formed using this kernel. So for example, if this is the kernel, then these are all for different values of k, these are the lines. So for k is equal to 0, this is the line, k is equal to 1, this is the line. So k is basically used as slope. So from now, given a line, what we do is for a given image, we place the kernel at the middle. Let's say the center of the kernel is IC, JC, and we place the kernel over I, J of the image. And for this line, we calculate what is the sum over this line, and so that, and we do it for all values of L. So for every line, we see that we calculate the summation over this line for a point. Then the assumption is that a line can be considered, a palm print can be considered as a straight line in a small locality. So if it is a palm print of this kind, then at this point it should be giving minimum value at this point, considering that the palm print is darker than the remaining image. So the minimum values would be at this angle. So from that, taking that into account, we calculate the minimum of this point. So and store it and call it store it as Eij for point ij. From this we do for each and every point, and we get the energy image. So we get the energy image. So from this energy image, so this is the matrix of all the Eij points. From the energy image, we need to, like here, as you can see, the prominent lines are visible. So the principal lines are actually visible here. So from that we extract by thresholding we extract the lines. So the thresholding is done, is not automatic. So all the values are sorted into a vector, and and experimentally it was observed that the index 2000 to 3000 was good for thresholding. The value stored at this index. So using that, the indexing was done. Then now, given this, we still have to remove the wrinkles from the palm print. So what we do is we have two assumptions, that a palm print cannot go in this form, like it started here at some angle and it basically its slope changed by more than 90 degrees. This cannot happen, assuming this. And the other thing is to remove some of the general wrinkles. Most of the wrinkles are basically, if the palm prints run in this direction, most of the wrinkles run in some other direction. So using these two properties, what we do is we consider two intervals. For each point, we have calculated this energy and stored this angle. So that what is the theta value for which it is minimum. So we store we have taken the minimum value, and then we know that whether it is less than 90 or greater than 90. So for less than 90 and greater than 90, we have two different images. So now we compare the sum of energies of let's say one is LA and LB, the other is LB. So sum of the energies of LA and LB are compared, so that we assume that the energy of the image containing the principal lines would be more than what the wrinkle contains. So using that, we can get the following image. So here is the wrinkles that are there, and here is the other lines. So now, so apart from that, not only this, we have to remove the noise that is there. Like you can see, these are the noise. So we find again all the connected components, and instead of like taking the first top 4 connected components, we remove the bottom part of the connected components. So these are the lines that are extracted, and this is there. So we have removed this using this finding the connected component. Then there are the results that I have obtained. So these are the lines, and this is the yellow one is the line that I have obtained. As compared to previous algorithm, for this particular image, the previous algorithm did not perform well, and this was the best that it could perform on as compared to any other image. And this is the performance of this algorithm. So it is considerably better than the previous. And this I did for images of Cassia and Polyu. These are the results on Cassia. So some of the lines, like here, this line is missing as in because of some thresholding, and like here there is a prominent wrinkle which we couldn't remove. But for most of the values, it's good result. And here is some, but most of the lines are detected in this. and the result was much better for the poly U. So in this most of the lines are detected. So even in this case you can see there are too many wrinkles, but still it detects the principal lines, and only very little part of the wrinkle is there. So experimentally we carried out to determine the value of ZP, and like the size is optimum when it is 15. For less than that it doesn't find the line, and for more than that the computation time is much more. And for the number of directional lines we chose to be 12. So for less than that again the same case is there. And
What is the accuracy of your system?
so as in accuracy, what is the if I get some.
How many cases it failed?
So for I did not run it manually for all the for checking it. I have to run it for all this thing. So I did for 40-50 images from both the database. So manually checking is
the concept was to find out some key based on this canonical structure. So if this canonical structure is stable across the more many images, then you can apply some function and find out some value. That is we call key for the match. So you have to create then that is the second part that must be tested now if it is stable.
so as in we had this problem earlier, but you said that you extract the principal lines, and that part can be tackled later.
That is the second part.
So considering the images that for this kind of image, like there are so many wrinkles, it
So for the same person you are seeing displaying these images? For the same person?
no, not for the same person. These are for different person.
You should show the same
Then
person.
I can show that. I just wanted to show that for even for the like here there are too many wrinkles. Here there is problem of some illumination at the corners, but still it gives some good result.
But that is also required. In the report, you should also show that for the same persons, what is the you show all the
Okay.
lines that come and try to find out how much similar they are.
Using
Good evening, madam. My name is Adarsh Krishnan. I'm a test administrator. My project title is fingerprint-based fuzzy board system. What I was given was to implement this paper, biometrics mobile template protection, using a composite feature vector. I will just briefly review what is the algorithm that it used. The fuzzy bolt system requires two steps. First, it is the encoding phase, and then there is the recording phase. In the encoding phase, we register a user, take its fingerprint, and store a composite map of the feature. This is the whole encoding phase. There is a secret key S. In the secret key, we append a CRC error checking polynomial, and then we using this secret key plus the CRC kit, we construct a polynomial by creating a by dividing the whole big key into small shreds of 8 bits, and then we add some false points, and then using the initial template the user given, we create some points in the system, and that we store. The decoding phase, the user comes with a query miniature. From this query miniature, we create the composite vector and then feed it back into the system and find out what are the genuine points in the system. If the genuine points that we get are large enough to reconstruct the whole polynomial, then we release the key. The biggest problem that there's another interesting idea that this paper proposed was to it assumes that during registration we can assume that the user gets a good ID image, but while verifying, it can be the case that the fingerprint quality is bad. So what it does, it takes for example, this is the template image, and we can see that only a portion of it is matching. So what it does is, while matching, it divides the image into 9 portions and try to match each of the 9 portions with the image. If any one of these matches, then we consider it as a match. This is the composite feature that the algorithm creates. For example, these are the miniature vectors that have xy coordinates and the theta value. So the composite vector that we make is from a center point. We join all these edges and store the distance value, the difference in the angle, and the relative angle of this value. So for each miniature point, we have a composite vector. So total, we will have a composite vector will, if there are n images in the system, then the composite vector will have n minus 1 features, and there will be some like n of these vectors. While implementing, I first coded in MATLAB, but there were some issues with because the algorithmic complexity was taking some time, and so I moved to Python. The system actually has more than 11 to 12 parameters that threshold at various levels. The paper doesn't mention most of these threshold values, so I have to assume something and move ahead. The current implementation doesn't perform well because of this, because of various threshold values. I have tried to tune it to some extent, but further tuning is necessary. For the testing, I have taken the IITK ruler database. It is a database that has 500 each 500 individuals have their entries in, and each individual gives 2 sets of data. So for the testing phase, what I do is I take an individual, use that image to register that individual, and then test it across the other 500 entries. But generally, the IITK ruler database is considered to be a low quality database. There are images in it that have a quality attribute more than 3 index. So the total matching was around 2.5 lakhs. It took me quite some time to do this. If I did a serial job on it, it would take something around 3 days. So I tried to parallelize it and assign it like on 20 of the machines.
How do you do that?
What I did is nothing. Just simply the data level parallelism divided the data set. So the current FAR and FIR rate that I am achieving is this is quite high because the system uses a lot of threshold values that I am not able to get those optimal values. The script that we have to generate the CRC, the ERR and CRR, that requires a similarity parameter. Since the system actually filters out the matching at various levels to get a uniform similarity score for a single threshold value is very difficult. So that approach of calculating ERR was ruled out.
He has implemented this thing in a short form and actually further improvement and some scope are there because at various levels different thresholds are there to test whether I would go to the test.
So for example, here in matching, what it does is if there are two miniatures that are to be matched, but first it tries to match this, and there is a threshold value for each of the lines, and if the matching for the whole of the image succeed, then it goes into another level where it tries to match each of the match component. So there are multiple levels in it. So
actually coming up with a cumulative score is not being done. Also some improvement over the things are required. He has implemented the things and parameters.
so it takes a lot of time to even run all these things because the parameters are not clearly specified.
Are you going to modify, define the things or no?
I can do some runs, but I can't guarantee it. Some improvement would be there. Like I can just give the runs in the system and see if something improves, and then I can report it back to compilation.
To do that.
Actually, he has only run all this system only once, and for the further improvement, more than once run are required.
My number 2 is on Input knuckle print ROI extraction.
Have you checked this one?
Yes, sir. I mean, I'm not seeing. I'll check.
Okay.
This is the flow of my presentation.
So those things are not important. You come to the result. So the other thing you have to show.
Yes.
I have noted down your. also presented, right? Jain's paper.
Yes, Johnson, Dr. Johnson.
Now tell me,
So this was the last thing which I did. This is the input image and this is the empirically cropped one where you don't require any computer. And this is the one which takes the intensity axis as the central axis and drops onto vertical axis. So, after that presentation we had discussed with Mr. Aditya. Then we had approached on comparing the images. We have already got a ROI cropped image from Polygon. We run a correlation on each of these images. So what I have done is that I had taken those images, that is 12 images I had taken. Each set there are 12 images. And what we have done is that we have taken the first image as a template and then correlation with the other 11 images, including itself. So now that is this was the thing. And for the first set we got this average is 0.8076. And this is the empirical one. Again, 12 of the same. We have taken one set of 12 images of the same person. Like I taken in total 4 fingers. That is left index, left middle, and right index and right middle. Each finger has got 12 samples. So with each of these methods, I have taken correlation with each of this. That is this image compared with other 11, including itself. Then again this with this. So when we see the comparison, then here in the first thing it appears that empirical one is not as good as the one which we already got, but definitely the one which I had proposed, the intensity method, that is better.
That one is the given cropped ROI.
This is a cropped ROI.
So you are saying that with the cropped ROI you are getting 0.8909 when you match first and second.
First and second, then first and third. First
Okay.
and fourth.
So and here you are getting 0.9022.
Yes.
So we will be checking the first column and the last column.
Yes.
And
I have done on other
corresponding
columns,
entries.
there are the values there. So this was the second one. Again it is coming out that
So as
this
you are trying to
intensity
say
is
that
better.
most of the time you have only matched, okay, so with first image and the second, then first and third, then first and fourth,
Yeah.
and then first
I
and
taken
fifth.
in all the things I taken first image as a template. So randomly I can choose anyone. But even this course might improve if I had taken the best image of among those things, but I had not done that. I had taken randomly that as I fixed it as the first image as template, then compared with the other images.
Okay. So,
So
you,
when
you are saying that in all of the cases, when you are fixing the first and you're matching with the rest, you are getting better correlation.
Better correlation in these both the methods, even empirical and intensity method. Only for few things it is not consistent. This empirical method is not consistent. Otherwise, it is, we can say it is comparable with the one which we are getting from Poly University.
So is it, how can I justify? Can you show that?
And I got 4 sets of data. Even other this thing I run, but I am not kept it because of the numbers again.
Well, I'll sit with them and let's see this.
so it looks that
Yes, that is correct.
This is what
yes.
yes.
And then, you know, ultimately you have to draw the final conclusion.
Yes.
What is the probability that you have done or extract the ROI correctly?
Yes.
Right?
Yes.
That is it.
This is the observation that what I found was that empirical one is not consistent. Sometimes it is comparable with that Poly University this thing ROIs, and sometimes it is less, and sometimes it is more than that. But the one which is based on the intensity one which we have calculated, that is slightly better than the Poly University one in all the cases.
9036 problem statement is not required. Now you come to the what you have achieved. Because I know that you are supposed to give me 4 parameters to be studied. Whether quality and recognition. These are the things.
So the result was not so good.
Not so confident.
And we take many value of the parameters.
They are getting such a big number. Yes.
What is that? 50%?
30.
What is CRR?
कहाँ पे CR है? CFR है।
On the set of 50 images, on a 450 images. Our database of 40 images, 50 images,
40
50
images.
on a set.
50 images, 30 FR है।
50 cross 50 folder.
50 plus 50 folders.
Each folder there are 6 images.
50 subject, 50 marks.
Okay.
Subject. 90%.
40 or 40.
40.
We have changed several values of S, but
Yes. Take my
कोड चेक किया है? कैसे?
For the same image, we get the matching score of 1.
वो तो आएगा ना क्योंकि वो तुमने जो फीचर निकाला होगा ना फीचर में कुछ गलती हुई होगी तो एक ही जब वही फीचर बन जाएगा तो हैमिंग डिस्टेंस निकालो तो वो 0 1 ही आ जाएगा.
Whatever is given the paper, we implement it.
Can you figure out what are the parameters जो कि तुम नहीं सेट कर पाए? ये क्यों इतना खराब है? How can you justify that it is only 40%?
there are like
इमेज की कोई प्रॉब्लम नहीं है. उनका तो आया ना, उनका रिजल्ट देखा है.
Sir,
It is very high.
in this paper,
Even if you use comp code, it is greater than that. ठीक है सर.
in
आप
this,
अगर
code,
comp
in this paper actually they use real part of the comp code.
ठीक है ना
So
वही
basically-
सभी कोई रियल पार्ट इस्तेमाल
But
करके
in the paper they written that if they use
imaginary
real
part
part then they can improve the.
अरे भाई मैं कह रहा हूँ 40% मतलब समझ रहे हो तुम खुद भी समझ रहे हो 40% CRR का आना I'm telling you comp even if you simply you would only comp code तो भी तुम्हारा जो भी तुम्हें 6 बिट लिए अभी 3 बिट का वेक्टर हो जाएगा उसकी एक्यूरेसी से ज़्यादा आनी चाहिए किस पे काम कर रहा है FKP पे तो उसकी एक्यूरेसी से ज़्यादा आएगी इवन I have coded that मेरा ये कहना है and actually sir was also saying कि if it is not working 40% it's just like that you require I mean you take some time you work on it you try to find out why it is 40% if it is 80 85 90% and
So
equal
remember they took the 6 bit, right?
yes 6 bit
And then I told them that you reduce the, that they are taking the 6 bytes.
yes same thing.
You remember that pin wise verification I told you?
I'd say that sir they'll again present conflict and just try to improve the accuracy 40% is very good.
They could have done it. Mark that also. They could have done it. Why?
You manually check the I'm saying you manually check given the image what is the code that you are generating is it correctly doing the thing 40%
Can you see the thing?
okay
No, but
मैं तो
they
sir,
did there.
अभी मैं इनको कुछ तो बता दूंगा after this you meet me but I'll see the thing again
They are about to complete, if I remember, but I noted
Yes,
down
yes.
this thing. And only I gave the final thing that bit was replaced and that kind of thing.
15th को सर देख लगे
Which is 16th or 16th.
ठीक होगा
This is a marathon.
yes 16th
Because
but should be at least 85 to 90%
yeah,
at
आपको
least
करना है at any cost. Because I want to see that your thing is going in good shape.
even if you use only comp code even that is better than this तुमने फीचर बनाया उसको देखा वो कैसा था दिखने में उसको तूने विजुलाइज नहीं किया उसमें कुछ तो गलत हो रहा है I'm telling you and that is the thing that by these all projects we wanted to let you people know that when you are using I mean working in biomedical what are the different problems and challenges that you used to address पेपर पढ़ लिया आप पेपर में पूरा समझ चुके हैं आफ्टर दैट यू हैव आल्सो कोडेड दैट थिंग तो अभी आपको इंटरनल मतलब चीजें भी पता है और उसमें जो प्रॉब्लम आई होगी वो पता नहीं कोई इंट 16 वाली कोई प्रॉब्लम आ गई होगी जिससे वो सबको जीरो कर दे रहा होगा या कुछ ऐसा हुआ होगा अंदर पक्का इसके बाद भी मिलते हैं
Mental to do brother. So the equation looking at there. What are the parameters? 4 parameters.
Parameters are actually
So for the quality parameters or what?
Quality.
Quality basically we can use this transform. Basically, what it can do that in that case we are taking two additional coefficient Rx and Ry. So basically, what is this that basically there is a reference image, which is a good image, and we take another image. So for both two images we are calculating 5 coefficients, and then we basically make a matrix. And basically we are storing these coefficients, and we basically are computing difference matrix. That we are using that by what he is doing basically it is every coefficient is multiplying basically very bit. And this is basically square and Rx. Basically we are, this is the one coefficient, finally we get five coefficient, and basically we multiply, then it will basically and divide.
What is the problem in displaying all this?
So what we have done is I had updated the results in the text file.
This formula you could have written.
Sir, this one of the slides were removed.
Huh?
So basically we removed this one.
Why? You would like to see that slide.
We can put it back now.
ठीक है, तुम लोग आप again 16 को present warning delay. Four, five.